The context window. Playlist 3, Episode 3. The advertised limit isn't the real limit. Last episode, we saw that an agent's bill is dominated by recent context, 62% of every dollar. So the natural question is, what's the actual limit? Claude says 200K. Gemini says 1 million, even 2 million. GPT, up to 1 million. Tons of headroom, right? Here's the catch. The published numbers are not the working numbers, and almost nobody tells you that. First, what is the context window? It's the model's working memory. Everything it can see in a single request measured in tokens. But everything is more than your message. The system prompt, a couple thousand tokens. Tool schemas, a few thousand more. Conversation history, growing each turn, your current message, and space reserved for the model's output. The model can't write into space that's already full. The window isn't just your input, it's the entire round trip. Input plus output, all sharing the same budget. Said again, the context window is the total budget for one request. System prompt, tools, history, your message, and the model's reply. All of it competes for the same tokens. Independent benchmarks, Chroma, NVIDIA, TokenMix, all land on the same conclusion. Models reliably use only 60 to 70% of their advertised window. A 200K model becomes unreliable around 130K. A million token model, closer to 600,000 or 700,000 effective. And the degradation is not gradual, it's a cliff. Among the big three, Claude's 200K window is the most efficient, less than 5% degradation across its full range. Gemini has the largest window but degrades earliest. GPT sits in the middle. Bigger window does not equal more reliable context. Often the opposite. Part 2. Even inside the limit, position matters. Where you put information changes whether the model uses it. Even within the window, the model uses well. Where you place information dramatically affects recall. Start 93% accuracy, end 91%. Middle drops to 76%, sometimes lower. Every major model shows this pattern. It has a name, the lost in the middle problem. Here's the detail, almost nobody mentions. When the window is less than half full, the middle gets lost first. When more than half full, the earliest tokens get lost. Your Claude.md, your project instructions at the top of a long conversation. In a long session, those age out of attention first. The anchor sinks. Final twist. Recent production data, 78% of real API requests use under 16,000 tokens. 16,000, not 200K, not 1 million. Most of the time, you're nowhere near the limit. The bigger window arms race solves a problem most real work doesn't have. What will bite you is what happens in long sessions and big repo workflows. 3 things to remember. 1. The context window is the total budget per request, including the model's output. 2. The advertised number isn't the working number. Effective capacity is roughly 60 to 70%. 3. Even within the working zone, position matters. Start and end win. The middle is where things go to die, and in long sessions, the earliest tokens drift out first. The advertised limit isn't the real limit. Position matters too. Next episode, Context Rot, why your agent gets worse the longer you talk to it. Subscribe, we crack open every bone.